This is Algebra 1, and I'm going to be working through the lesson, the very first lesson for Algebra 1 for the Algebra 1 course. And the first thing I do when my kids come to my class, beyond just introductions and other things the school is doing, we have a lot of activities, or had a lot of activities where the kids would get to know each other. One of the very first assignments I give them is distance versus time. And so I just wanted to show you exactly what that looks like. So when you go to, if you don't already have this slide presentation, this will be available in the show notes, but this is going to give you the links out to the different activities that you can do with this lesson. And the first lesson is called Walk the Graph. It's also called Walk the Line, or it can also be called a lot of things, but basically the kids are going to create graphs with their bodies. So let me show you what I mean. I've done a blog post called Making Sense with Movement, and you'll see here an example of something a student created with this assignment as the graphic, and this is the tool that I used. This is called a CBR. They have other tools available, and if you look at the links, I'll show you those, but there's other ways to do this, but I found this was very inexpensive. I got this used off of eBay for like, I think I paid $15. I'm not sure. It wasn't very expensive. This calculator, I just had it left over from ages ago, and I actually broke the calculator that you're looking at right here in this picture, and I started doing this with a TI-84. I had no idea that a TI-84 would work. It's one of the older models, not the CE, not the newer one, not the skinny ones, but the kind of the fat ones. And it worked. It worked great. So if you have any of those older model TI-83s, 84s, they should work fine with this CBR. And if you don't have any of these tools and you don't want to spend a lot of money, you can probably find all this stuff used online. That's exactly what I did. But this basically shows you what the kids did. And this little short video I made of a student. I got her mom's permission to take her picture, but she does have a mask on. But this is how they walk in front of, you can hear the little popping sound. She's laughing. That little folder is actually for a purpose. It's using like a sonogram kind of thing, and it's shooting out these little pulses, and it's bouncing off of a surface and coming back, and that's how it determines the distance and creates the graph. So I usually have kids put a folder or something like that in front of their body so that it has a flat surface to bounce off of, and it does make the graph a little nicer. But this blog post, you can get a link to it, and it describes our activity. It's so much fun. If you've never done this activity, I highly encourage it. And a more official version of this activity is also linked, and this one is from UCubed at Stanford University, and they describe this activity of walking the graph, and they give some examples. They're using a different equipment. Let's see if I can find the name of it here. Let's see, it says you would use a laptop, TI SmartView software, LCD projector, and then a CBR2 TM, CBR2, and a Vernier Easy Data app. Okay, well, I didn't use any of that, and I did this, but you don't really need the SmartView. I would encourage you just to use a document camera, put the camera right on the face of the screen, and just show it right off the calculator. That's how I did it. You don't need any special equipment if you do it that way. But they do show you how to do it here with a little more specificity. So you can read through that if you're wanting to do this activity. If you're going to do this one, I would do it first, because it gives kids a really good intuitive understanding of what the graph's doing, and they make sense of a rising graph does not mean going up in the air. A lot of kids think that until they start making these graphs, and they realize, oh, I back away, the distance increases, so the graph is rising. So they learn a lot. All right, the next thing in our list, after Walk the Graph, I would probably spend about a quarter to half of a class period working on this, and the kids create their little graphics to go with it. This is not a full class activity. if you're on a 90-minute block, and I was on like a 100-minute block at this time, it took me less than half of one of those class periods. So I would move on in the first day to a second activity, and the second one I have not done this exact one, but I've done ones like it, is a GeoGebra activity. So if you'll click on this link, it's going to take you out to this activity, and it's called Velocity 1. Now when you click play, you're not going to see anything because there's nothing to display until you choose one of these. So click on road and you press play, you'll see the little car moving. You click on the graph, it'll create a graph of the car, then the markers, and then photos along the way. I usually have the kids do these one by one, and then they can do them all at the same time. Reset and do it with all of them. Once they finish doing a graph, you can ask questions about the graph. You could display it for the class. You could call on kids to explain what's this car doing, what is this flat part of the graph revealing, and so on. But what they would do is take a picture of this, put this in their slides, their Google Slides, and then type some text. What happened? What's going on? I'm usually not too picky at this point because we're just getting started, but you may call their attention to seconds and meters and have them maybe use those words or ask them to use those words. They probably won't if you don't ask them to, especially initially. As we go through these activities, my instructions become more detailed about what I'm looking for. So before when they start this walk the line or walk the graph activity, I may not be picky at all. But as we go along, I'm like, can we put some more information here? What are our units? What's happening? Is this fast or is this slow? What does it mean? Horizontal, the graph, it means he stopped. So I would ask them to add more detail maybe to their graphs. All right, so that's day one. You may be finished, or you may be able to go ahead and do turtle crossing. On turtle crossing, it's a Desmos activity. This is not a paid activity, so you don't have to pay for Desmos Classroom to use this one. It is a free activity, and it is highly engaging. If you do start the class with it, you may want to, I don't know. They love this one because what you can do is they can draw nonsense like this, and then when they press play, the turtle will split into mini turtles and do kind of crazy things. We could talk about that here. I do ask kids, why is it doing that? Why do you have 3 turtles in some of these places? And so the definition of a function would come up. You could ask them to make him travel at a constant rate. You could have them make him speed up, make him slow down. You could spend a long time on this warm-up. So depending on when you're doing it and how much time is remaining in your class, take the time to have some good conversations here. One cool feature of Desmos is you can display kids' graphs. So you could actually take a picture of a student graph, display it. You could put it up in front of the class and ask questions of the student, of the rest of the class. And sometimes kids ask, pick me, pick me. They want me to put their picture or put their graph up to discuss it and play and see what happens. So good opportunity. There's 10 slides here, so this is sort of a full lesson, and here's where you're getting more and more into specificity. Like, tell me what it means, feet per second. What does that mean? Tell me how far this turtle traveled from the water. Where will you see that in this graph? Tell me how long it took for him to cross to the other side. Where do you see that in this graph? And just ask those types of questions. Where was he traveling slowly? Where was he stopped? And how do you know? And what does it mean? Instead of saying where, maybe we should not say where, but what time. At what time? And what distance was he stopped? So those are good questions. Again, the detail should be growing over time. So I'm working on probably day 2 here. I might even come back to this activity after they've slept on it, and let's get some more detail, and the kids can come back in here and put some more detail into their activity. And you do have extensions at the end. So not the reflection, but this one right here, I call this an extension because it's a pretty tough one. You're trying to get across here without hitting any of those little snakes. So he may have to back up or stop or slow down to make that happen. All right, turtle crossing would definitely get you through day 1 if you have a typical block schedule. Probably you're going to be well into day 2 before you get through with turtle crossing. And then the next activity I have is graph the seagull. Now this one, I actually gave this in a different sequence one year, and so this was kind of my starting activity. So I don't have as much detail in my student work samples for this that I would probably have if I were giving it on day 2. But this is an activity in Desmos, but it really works well to do this at the whiteboards. So if you have ever done building thinking classrooms, you could use this activity on the whiteboard. The kids could just come up and create a graph, and then we could talk about it and, you know, whose graph is better, what could we do to make it better. But it's basically saying, consider how the seagull is moving. Sketch a graph that represents the movement. And I've intentionally left off movement how, movement from where. And I do have kids interpret this differently. Like, you could graph his distance from the snack. You could graph his distance from the door, which most of my kids do that. They graph his distance from the door over time. And so I even had somebody graph his speed, which I found was interesting. It wasn't actually a good graph of the speed, but he said he was graphing the speed. So you would use sort of horizontal line segments for speed, I suppose, maybe for the 2 sections or 3 sections of the graph. But I do ask them to label with a quantity and a unit. They did not do that in my student work samples. Or at least one of them is not done. It's because I didn't have that in here when I gave this initially. And then label the vertical axis with a quantity and unit and explain how you created the graph. So they have this tool where they can draw line segments. They can change the color. They can type numbers and math. They can type text. So if you're doing your labels, the kids can use text. I'm actually using these activities to teach kids a little bit about how to use some of the tools in Desmos as well. So I'm kind of building that into my instruction the first few days of school. And the next lesson, you'll see quite a bit of where they're using the Desmos calculator and some of those features. So I'm using this as a dual purpose to see where they are on reading a graph and interpreting. Because honestly, most of what I'm asking them to do here would have happened in their 8th grade math class. But I'm also trying to see how well they're comfortable with the technology, if they've used it before, and then filling in those gaps if they need help. So the next thing after graph the seagull was hare and tortoise. I've already got that one. Now this one is a full set of resources, and it is actually on paper. So these are Google Docs and PowerPoints. You can assign this PowerPoint. I believe you can convert it to a Google Slides and assign it. If you're in a school with Microsoft, then you can assign the PowerPoint and have them work through it. It's actually a quiz. I don't know if it'll function that well in Slides because I haven't tried it, but it's kind of cool. Or you could just do it as a whole class. If you want to just put it up and go through it as a class, that would be a quick, like, you know, summative activity for the day to see where they are. They do have different graphs, and they have to describe them. So I liked this one. This is more traditional pencil paper, but it's a free activity and it has a lot of reviews, so you can read through those to get some ideas. And let me show you all the features they have. They have this where you have to pick a graph and match it to a description. And I don't know why they have 2 of the same in here, but they do. So anyway, that's the lesson for that, and that's more traditional. If you don't have time, you may not do all of this. You may just do one piece of it, or you may do none of it. I mean, if your kids are doing extremely well, this may not be necessary. The last thing I have them do, and this is sort of like a mini assessment, is have them do a card sort. And this is challenging. So they may have to spend some time on it the next class period if you decide to do it. There are a lot of slides here. So when you put these together, that'll help clear up some space. But it's talking about Tom walking to the store and then coming all the way back. And all of the graphs are distance from home over time. So you'll notice one of them, he goes to the store and then he comes back. So maybe that's that one because he's at the store. but he ran back, so maybe it's this one. So anyway, you put them together like that. When you click these little arrows, it shrinks it down so you have less cards in the way. So once they've done that, they go back over here, they click on check card sort. So it is self-checking. And then the last one, you have to finish your card sort to get this question, but it asks them to create a story for the one graph. So there's one graph that doesn't have a description. It says make up your own. Right here, make up your own story. So on that one, they'll make up their own story, and that's a fun thing to share out, so a good way to end the class period. I did want to show you a copy of the student slides. This is what they would get, and I would assign this through Google Classroom. So whatever your LMS is, I would give each kid their own copy. It will have the sequence of activities, so of course if you don't want to do all of these, you would modify this to suit your lesson. You might even split this into 2 different slide decks if you're going to do this over a period of 2-3 days. But this is what they'll get. So they'll get a blank slide with directions. I do give them notes down here at the bottom that say showcase your understanding. What are the units? What direction did you move? So I ask for lots of detail. You may decide not to do that initially. Sometimes I choose not to give them any direction initially just to see what they're doing. But I do have them delete these directions. So whatever, I want them to delete these directions, put their images of their calculator, put some color, put some text, give me some descriptions, make this pretty, make it look nice. They do have to do a portfolio, and so I encourage them to be very creative and colorful and interesting so that they can pull these tasks and put them in their portfolio. Once a week I give them an opportunity to update their portfolio, and so they go back through their lessons and pick something out that they've created. This is an example of something they've created, and so it would be eligible for their portfolio. So that's what that is. And then these are the screens they get for traffic velocity, and it just gives them the link to the activity. So the link is actually right here inside their assignment. They describe the graph. They talk about the movement in the graph. Down in the notes at the bottom, I give them more specific. I might give them some vocabulary. Like here, I say, use some of this language: increasing, decreasing, constant, stopped, moving forward, moving backward, and so forth. But anyway, they'll get one for each of the slides. If you want to do more, you could add more slides. If you want to do less, you could drop off a couple. This does have a system. A couple of systems in here actually, so if you don't want to get into systems because you want to do that later, you could delete that one. So that's totally up to you. All of this, you're going to be making a copy of this if you use it, so you can edit that and use it however you would like. So that is the slide deck for the students that you would assign. I did want to show you some of the student work samples. Some I had to create for you, but most of these are actual student made from start to finish. And so the ones at the top, these were made by students. These are their calculator screenshots. They took those with their Chromebooks. They inserted them into slides. That's what this one is. And then they put some text. She used little cut and paste text. And she even drew her graph again with her tools inside of Google Slides. This person just took a picture and labeled the picture with a text box. Same here. She took a selfie and then labeled it. This is somebody's portfolio. They took their picture of the seagull that they created. They took that graph and put it in here and did a long description of how they created that graph. And this one has the text box in the graph and talks about the seagull walks away and then back. When he walks fast, the graph is steep, and slow, it's flat, and so forth. This would be work samples from the GeoGebra. So 3 of the problems. I gave the students 1 slide for each of the first 5 velocity graphs. I typically won't go over 5 of anything because I don't want them to get, I want to move on to something else. After about the 5th one, they'll stop thinking and they'll just start answering without thinking. So about 5 is my limit, and so I did give you 5. There's one last link I do want to show you, and that's here in the Desmos activity. When you click on this link and open this assignment, it will take you in here, and this link is the map site. So this is another activity. This one again takes some time, but it gives you the rationale for the assignment that you see. And these are pencil paper. So let's say you really just don't want to work on the Chromebooks one day. You want to do some of this without the Chromebooks. This would be a great activity. They also have the cards in here. Let's see if I can find them. Yeah, here they are. You could actually cut these out and give these to the kids and have them match these distance time to these. So this is basically the same activity, but they do go a step further and do these tables. So these tables are pretty cool. You could actually match those. So if you don't want to use the Desmos activity, this is a real cool one. So this is the distance time lesson. I hope that you found it interesting, and I do hope you'll use it with your students. If you do decide to use it, please take pictures, send them my way. I would love to hear your stories. I would love to see your student work, and I would happily display it for the whole world to see. So if you want to share a really special graph with me, I would be thrilled to receive it. Y'all have a great day.